Assalamu alaikum dear students, I hope you all are fine. Today we are going to continue unit number 4, which is about factorization, HCF and LCM. Third method for find the HCF is by long division method. Here is some simple properties of divisibility. The first one property is if a number is divisible by another number, then the former number is divisible by all the factors of the later. Here is an example. Next relate the example with the statement 12 is divisible by 6. Then the former number is 12, is divisible by all the factors of the later. Later number is 6. 12 must also be divisible by all the factors of 6. Here the factors of 6 are 1, 2, 3 and 6. 12 divided by 1 is equal to 12. 12 divided by 2 is equal to 6. 12 divided by 3 is equal to 4. 12 divided by 6 is equal to 2. So this statement is true for the first property. Second property is if a number is divisible by two or more co-prime numbers. Students, you have already knew about the co-prime numbers in the previous lecture, numbers whose HCF is 1. Then that number is divisible by their product. Relate the example with the statement 24 is a number which is divisible by two numbers 3 and 4. And the 3 and 4 are the co-prime numbers. The product of 3 and 4 is 12. Also 24 is divisible by 12. Property is if a number is a factor of a two or more given numbers, then it is a factor of their sum. The two numbers are 12 and 18. 6 the factor of a 12 and 18 because 12 is divisible by 6 and 18 is divisible by 6. And the sum of 12 and 18 is 30. 6 is also the factor of 30 because 30 is divisible by 6. Last property of divisibility, if a number is a factor of two given numbers, then it is also a factor of their sum difference. The two given numbers are 32 and 48. 8 is a factor of both 32 and 48 because 32 is divisible by 8 and 48 is also divisible by 8. Here is the difference of 48 and 32. 48 minus 32 is equal to 16 and 16 is also divisible by 8. Students, this is the important point for find the HCF of the two numbers out of two given numbers. The two given numbers are 8 and 16. If one is divisible by the other, 16 is divisible by 8, then the smaller number is the HCF of the given numbers. The smaller number between these numbers is 8, hence the HCF of the given number is 8. Same as it is HCF of 10 and 30 is the smallest number, that is 10. Students, next we solve example number 4, which is about division method. Find the HCF of 516, 1935 and 3000 by the division method. Firstly, find the HCF of the first two given values 516 and 1935, where 516 is the smallest value, so we take outside of the bracket, and 1935 take inside of the bracket. Next, divide both these terms 516 and 1935. 516 3s are 1548. Thirdly, subtract these two values. 5 is the smallest value than 8, so carry from 3. It becomes 15 minus 8 is equal to 7, and 3 becomes 2, so carry from 9. This is 12. 12 minus 4 is equal to 8 and 9 becomes 8. 8 minus 5 is equal to 3. 387 take outside and 516 take inside. Next, divide these two numbers. 387 ones are 387. Then subtract these two numbers. 6 is the smallest value than 7. So carry from 1. 16 minus 7 is equal to 9. 9 becomes 0. So carry from 5. 10 minus 8 is equal to 2 and 5 becomes 4. 4 minus 3 is equal to 1. Next, divide 129 and 387. 129 take outside and 387 take inside. 129 3s are 387. If we will get 0 as a remainder, so the last divisor 129 considered as the HCF of the 516 and 1935. 0 is the smallest value, so carry from 2. 0 becomes 10. 10 minus 7 is equal to 3 and 2 become 1, so carry from 4. 2 becomes 11. 11 minus 8 is equal to 3 and 3 minus 3 is equal to 0. 33 is the smallest value than 129, so further division is not possible, so 33 take outside of the bracket and 129 take inside of the bracket, and divide these two terms. 33 3s are 99. Subtract these two values, so we will get 30, and 30 is also the smallest value, 33. So 30 is not divisible by 33, so 33 is take inside of the bracket and 30 outside of the bracket. Next, divide these two terms. 30 ones are 30 and the remainder is 3. 3 is the smallest value, then 33 is not divisible by 30, so 30 is take inside of the bracket and 3 take outside of the bracket. 3 tens are 30, the remainder is 0. When the remainder is 0, the last divisor considered as the HCF of the given three values. The given three values 516, 1935 and 3000. Hence the HCF of the given values is 3. We will continue exercise number 4a by question number 7. A room is 12 meter 15 centimeter long. The length of the room is 12 meter and 15 centimeter and 8 meter 91 centimeter broad. The width of the room is 8 meter and 91 centimeter. The floor of the room is to be paved with the square tiles. Find the length of the largest tile that can be used. You have to find the length of the largest tile that can be used for paving the floor of the room. The given length of the room is 1215 centimeter, where 12 is in the meter. So firstly you have to convert this meter into the centimeter. As you know that students, 1 meter is equal to 100 centimeters. Then multiply 12 with the 100. 12 into 100 is equal to 1200. Then we will get the length into the centimeter. 1200 plus 15 is equal to 1215. Follow the above solution for find the width of the room in centimeters, where width of the room is 8 meter and 91 centimeter. 8 meter, which is equal to 8 into 100, and 800 plus 91 is equal to 891. When you find the HCF of the 891 and 1215, then you will get the length of the largest tile. Next, find the HCF of the given two numbers 891 and 1215, where 1215 is the greatest value, so take inside of the bracket, and 891 take outside of the bracket. 891 ones are 891, then subtract these two terms, will get 324, where 324 is the smallest value than 891. So further division is not possible. 324 take outside of the bracket and 891 take inside of the bracket. Then divide these two terms, 324 2s are 648. Subtract these two terms, will get 243, where 243 is the smallest value, then 324, again 324 take inside of the bracket and 243 take outside of the bracket. Divide these two terms, will get 243 ones are 243. Subtract these two terms, will get 81. 81 is the smallest value, then 243. 243 again take inside of the bracket. So 81 3s are 243. The remainder is 0. So the last divisor is 81. Hence the last divisor is considered as the HCF of the given two values 88, 91 and 1215. Next question is question number 8. Find two numbers between 100 and 150 with the HCF 24. The HCF is 24. Students, you have HCF already, which is 24. You have to find only two numbers that are lying between 100 and 150, not less than 100 and not above 150. The given value of HCF is 24. Next, find the multiples of 24. The first multiple of 24 is 24. When you will add 24 and 24, you will get the second multiple of 24. When you will add 24 and 48, you will get the third multiple of 24. 96, 120, 144, 168 and up to so on. These are the multiples of 24. 120 and 140. Students, you can easily see that 120 and 144 are the numbers that are lying between 100 and 150, not less than 100 and not above 150. So these are the two numbers that are lying between 100 and 150 with the HCF 24. What is LCM? The least common multiple. The smallest common multiple of two or more numbers is the least common multiple, LCM. If you have to find the least common multiple of two or more numbers, then you have to firstly find the smallest common multiples of those numbers. Simply the smallest common multiple is called the least common multiples. Students, as you know the properties of HCF, next discuss the properties of LCM. The first property of LCM is the LCM of two numbers of which one is a multiple of other is the multiple itself. The LCM of two numbers, the two numbers are 12 and 24, of which one is a multiple of other. 24 is a multiple of 12, is a multiple itself. When you will find the LCM of two numbers 12 and 24, then the 24 is also the multiple itself, 1 into 24. The second property of LCM, the LCM of two co-prime numbers is the product of the two numbers. The co-prime numbers are 3 and 4. 3 and 4 are the co-prime numbers because their HCF is 1. Find the LCM of 3 and 4. The answer is 12. Students, you can see that the answer is 12. 3 4s are 12. So is the product of the two numbers. This statement is true for the state property. There are three methods for find the LCM. First one is common multiples method, second one is prime factorization method, and third is by division method. Find the LCM of 32, 36 and 48 by prime factorization method. The prime factorization method is the second method for find the LCM. Firstly, find the prime factors of 32. Start with the smallest prime number 2. 2 1s are 2, 2 6 are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. These are the prime factors of 32. Here we use 2 raised to power 5 because 2 is being multiplied 5 times. Next, find the prime factors of 36. Start with the smallest prime number 2. 2 1s are 2, 2 8s are 16, 2 9s are 18, 3 3s are 9 and 3 1s are 3. These are the prime factors of 36. 2 is being multiplied 2 times, so 2 square, and 3 is being multiplied 2 times, so 3 square. Next, find the prime factors of 48. Start with the smallest prime number 2. 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 3s are 6 and 3 1s are 3. These are the prime factors of 48. Next, find the LCM of these answers. Product of all the prime factors with the highest power. You have to find the highest powers of the prime factors. The highest power of 2 is 2 raised to power 5. The highest power of 3 is 3 square. The answer of 2 raised to power 5 is 32 and 3 square is 9. 32 into 9 is equal to 288. This is the LCM of the given values by prime factorization method. Exercise number 4b. Question number 2. Find the LCM of the following numbers by prime factorization method. The question is 42, 48, 56. Follow the above example. By prime factorization method, you have to find the LCM of these numbers. Find the prime factors of the given these values one by one. Firstly, find the prime factors of 42. The smallest prime number is 2, 2 2s are 4 and 2 1s are 2. The next prime number which divides 21 is 3 7s are 21, 7 1s are 7. The prime factors of 42 are 2 into 3 into 7. Next, find the prime factors of 48. Start with again smallest prime number 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 4s are 2 2s are 4, 2 6 are 12, 2 3s are 6 and 3 1s are 3. These are the prime factors of 48. 2 is being multiplied 4 times, so 2 raised to power 4 and 3 again 3. Next, find the prime factors of 56. 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 4s are 8, 2 7s are 14 and 7 1s are 7. These are the prime factors of 56. Prime factors of 56 are 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 4s are 8, 2 7s are 14, 7 1s are 7. These are the prime factors of 56. This is an important statement for find the LCM. Product of all the factors with the highest powers. You have to choose the highest power of the prime factors in the answers. So the highest power of 2 is 2 raised to power 4. The highest power of 3 is 1 and the highest power of 7 is also 1. 2 raised to power 4 is equal to 16. 3 7s are 21. 16 into 21 is equal to 336. Dear students, do practice of SIVA questions and do homework of question number 5 fourth part. Question number 2 second part of exercise number 4p. Also learn definitions. See you soon in the next lecture. Take care. Allah Hafiz.